when you have to graph polynomials without being able to make a large table of coordinates, that's usually very time consuming. So I thought of this question as a way to condense the information that you need to know without requiring too much work. So you need to know a lot, but you don't have to do too much math to figure it out. Okay? So let's see how well you can do this. The first item asks you to use the leading coefficient test to determine the graph and the behavior. So we're talking about the graph of a polynomial function. The leading coefficient is the coefficient, the number, multiplying the highest power of x. So this is the leading term, and the leading coefficient is 1, because it's 1 times x cubed. Okay? So 1 times x cubed is the thing that shows up. Because the power here is odd, we are graphing this following the model of any other odd polynomial, such as a line. So this is y equals to x, right, to the power of 1, which is odd as well. And when that happens, you have this type of end behavior. So you can just erase the middle behavior here, and those will have the same behavior. It could also happen that those get switched around. You know that. If you had a -1 in here, it would be going down, going up like that. But there's no reflection, so we are good. The end behavior is that the function or the graph falls left, so falls to the left, if you want to be more precise, and rises to the right. Okay? So this is the end behavior. We don't know what happens here quite yet. Like in the middle, we don't know what will happen, but we know that as x becomes really large, positive, function goes up. When it's really large, negative, function or graph goes down. So that is A. On B, we are trying to find the zeros of the function. So this is where what I said applies. I'm trying to make this not too difficult while still including some information. So this is what I would do. You can solve this however you like, as long as you're able to explain it to me in writing. But I would do this by first factoring x squared out of these two, out of this first two. And then if you factor out a -9 out of that, I believe I made a mistake here. I believe this is a plus, correct? So this is a plus. So correct that. And then if you factor out your -9 out of this, out of these two right here, these two, you get an x plus 6. Double check my math. I believe I'm correct. The good thing about it is that now this guy shows up twice, so you can factor it out. So this comes here, and the only things left, x squared and 9, show up. This is the difference of squares, notable product, a special product, that I can factor out as this. So I thought of this question just so this would happen, so it would be not too hard to solve. Random cubic functions are pretty difficult to solve, to find the zeros of. So I have 3 zeros. X equals to -6, x equal to +3, and x equals to -3. So these are the 3 points where the graph crosses the x-axis. These are 3 x-intercepts, or 3 zeros. We got to decide whether the graph touches and turns at the x-axis or it just crosses the x-axis, and that's compared to the multiplicity. So same thing, you're comparing it to 2 known type of functions. So you're always comparing it to y equals x and y equals x squared. You know, the graph of this guy at the 0 right here is just crossing, and of this guy at the 0 is touching and turning like that. So these are known graphs. If I ever have an exponent of 2 in one of the powers here, let's say that 2 I just put there for example, and that means the graph is like this, near that 0, which means the graph touches the x-axis and turns at that point. But that doesn't happen in my case. So in all cases, all powers here of 1 All the three zeros have a power of 1. So multiplicity is 1. So this is what happens. The graph crosses the x-axis at all zeros. Pretty easy to change that question, right? Maybe just add a 2 somewhere, make it happen, make it so that one of those is one of those cases, which is also going to change how you need to factor, so make sure you practice that kind of idea. Next, we want to find the y-intercept. That's the easiest thing to do. The y-intercept is the point where the graph touches the y-axis, which is when x equals 0. So when x equals 0, go back to the original function, right? F of 0 is, so this is 0, this is 0, this is 0. Just have minus 64, or 54, excuse me. In fact, it's not here, right? It's at the bottom. So I have the negative 54 right there. So this is the y-intercept. Always box your answers or underline them. Do something to make it easy on me to find it. Put a drawing to make it more obvious. Always a good idea to do. Lastly, and also a summary of everything we've done, is using the information to sketch the graph. So start marking the points that are most consequential. The points are, first of all, the zeros. So minus 6, 3, minus 3. Minus 6 is all the way over there. So maybe I'll graph this a little differently. I have to go further to the left than to the right, so I'll leave some extra left space on my graph. So this will be my negative 6. This will be my 3, my negative 3 right here, and my positive 3. Okay, so these are the 3 points that kind of pin my graph. It needs to cross the x-axis right there. It doesn't touch and turn. It's not like this, right? Just figure it out. It's like this or like this on each of those. Just have to understand which one. I also have the negative 54 that I just figured out right here. Just have to go through it as well. The end behavior, right? It's supposed to go up to the right and down to the left. So right here, the graph is supposed to be like that. Right here, it's supposed to be like that. All I have to do now is connect the dots by following the rules we just agreed upon. So this goes up here, it needs to cross, and it goes back down, needs to cross, needs to touch that point, and needs to cross right here. So that is pretty much what my graph looks like. I could get more information if I wanted to, but that's fine. That is enough to get a rough idea.